Hey guys, it's your fellow cranky classmate here, and we're going to be doing a Unit 2 MCQ that covers differentiability, derivatives, and rate of changes. So, this first question, let f of x equal, from x is less than 1, x squared minus ax, and then from x is greater than 1, we have ax plus b, where a and b are constants, and if f is differentiable at x equals 1, then a plus b equals. So the first property of differentiability is that the function has to be continuous. So we need to first find it to be continuous. So we're going to make each of these equations here equal to each other. So we have x squared minus ax is equal to ax plus b. And then what we're going to do is we need to find it at the point x equals 1. So we're just going to plug in for x equals 1. So 1 minus a is equal to a plus b. Now, we're going to be using this equation later because we really only need to find the a plus b value, which means that we only need to find the a value because it equals 1 minus a. And another property of differentiability is that the derivatives also have to equal each other. So we're going to find the derivatives of each equation. So 2x minus a is equal to just a. B won't have, the derivative of b will just be 0 because it's a constant. So we also plug in for x equals 1. So 2 minus a is equal to a, and quick solving for a is equal to 1. So we're going to look back at this equation right here. 1 minus a is equal to a plus b. So all we need to do is plug in the a value. 1 minus 1 is equal to 0, so a plus b is equal to 0. In this next equation, or in this next question, find an equation of the tangent line to the graph of f of x is equal to x plus 3 over x squared plus 1 at x equals 1. So to find the tangent line, we need to first find the value of the slope at x equals 1. And to do that, we need to find the derivative and plug in x equals 1. So to find the derivative, we need to do quotient rule. Now quotient rule, unlike product rule, has a pretty big equation that I'm going to write down for you to know, but then I'm going to erase it for room. So the equation for quotient rule is f of prime of x, g of x, minus f of x. Actually, hold up. We're going to do something different. F prime, we're not going to do f of x, times g minus f times g prime over g squared. The f is just f of x and the g is g of x. Don't get confused. And remember this equation and write it down if you need to, because I'm going to delete this. Pause it if you need to. So using f as x plus 3 and then g as x squared plus 1, we can do the derivative of our f, which is just 1, and then g, which is x squared plus 1, minus our f, which is x plus 3, times our g prime, which is really just 2x, over our g squared, so x squared plus 1 whole squared. And we don't really need to simplify anything. It's pretty a big pain to simplify. All we need to do is just plug in x equals 1, and it's a pretty easy equation to plug in x equals 1. So we have 2 minus 4 times 2, and then when you plug in back into x squared plus 1 whole squared, you get 4. So our value simplified here would be negative 6 over 4, which equals negative 3 over 2. And only one equation has that slope value of negative 3 over 2, and that would be a. This next question here asks, the graph of the function f is shown above. Which of the following statements is true? So let's look at a first. F is discontinuous at x equals 0 because the limit as x approaches 0 of f of x does not exist. Okay, so it seems like all of these questions just ask for discontinuity. So remember the laws of continuity is that the limit of x approaches c of f of x must exist. And then f of c must exist. And they have to also be equal to each other. Remember that. So let's look at x equals 0, and it says the reason why that's discontinuous is because the limit of x approaches 0 does not exist. So looking at x equals 0, we can see that from the left and from the right, it does approach x equals 1, or y equals 1. So that means that the limit is true, but what they should have said was that f of 0 does not exist, which it doesn't. So that means that this answer choice does not work. This next answer choice, f is discontinuous at x equals 3 because the limit does not equal the value of f of 3. So looking at x equals 3, the limit from the left and the right is 0, so the limit is 0. However, the value of f of 3 is actually 2, and these don't match up, which I just said the limit and the value have to equal each other. So this is discontinuous by jump. So we're gonna look back at that, but let's look at every other answer choice. F is discontinuous at x equals 5 because the limit from f5 from the left of f of x does not exist. Remember, when it has a 5 and then a little negative, that means it's from the left. So looking at x equals 5, we're just looking at the value from the left, and that is 4. Now, that does exist, so this answer choice is just completely wrong. And it would really need to consider both the left and the right for the limit. So this is wrong. And then our final statement, f is discontinuous at x equals 6 because the limit from 6 to the left of f prime, it does not equal the limit of x approaches 6 from the right of f prime of x. Now, you only need to consider the derivatives when thinking about differentiability. You don't need to do that for continuity. So and since this doesn't consider the actual f graph, we don't really need to consider this answer choice at all because we have a suitable answer choice right here being B. So this next question, the graph of the function f given below consists of 3 line segments. Find the limit as h approaches 0 of f of h minus f of 4 over h minus 4. So this limit seems pretty complicated. However, it's really just the alternate form of the derivative, which, looking at it, means that we need to find the derivative at x equals 4, which is pretty simple enough. You just have to do a simple rate of change. So this line is pretty straight. So we go down 1, 2, 1, and then we go right 1, 2, 3. So that means that the slope for this entire line is negative 2/3. And that means that the limit is just negative 2/3. So while it seemed like a pretty complicated question, all you really need to do is recognize that this limit equation is just the derivative. So this next question, number 6, says, the graph of the function f consisting of 2 line segments is shown in the figure below. Let g be the function given by g of x is equal to 3x plus 1, and let h be the function given by h of x is equal to f of x times g of x. What is the value of h prime of 2? So, in order to find the value or the derivative of h prime, remember, it's just product rule, which we're going to write right here, f prime times g plus, not quotient rule does minus, and then product rule does plus. F times G prime. And then product rule doesn't have the G squared at the bottom, like quotient rule. So finding F prime of 2, we have right here. And to find that derivative, it's just a simple slope of from 1 to 4. Or sorry, yeah, 1 to 4. And to find that value, we just go 6 down and then 3 right. So that means that the value of the derivative is equal to -2. So -2 times g of 2, which when we plug into the g equation is just 7. And then we have f of 2, which is just right here we have, sorry, that little dot isn't proper. Right there actually, it'll be just 2 times g prime of 2, and the g prime equation is really just 3, which means for all x, so that means that g prime of 2 is just 3. And simplifying this, we have -14 plus 6, which is just -8. And let's look at this final question, which is let g be a differentiable function such that g of pi over 3 is equal to 3, and then g prime of pi over 3 is equal to -1. Let the function defined by h of x is equal to g of x times secant of x. What is the value of h prime of pi over 3? This one is yet another product rule question. So h prime of x is equal to g prime times secant x plus g times, and the derivative of secant x is secant x tan x. These are some of your derivatives that you have to memorize, so remember, if you didn't know that, then you should know that by now. So plugging in for pi over 3, we have the g prime of pi over 3 right here, which is -1, times secant of pi over 3, which is just 2, plus g of pi over 3, which right here says it's 3. And then we have secant of pi over 3 once again, which is just 2. And then we have tan of pi over 3, which is just √3. So simplifying all of this, we have -2 plus 6 times √3. So our answer here will be A. Thanks for watching this Unit 2 MCQ. Please like and subscribe and share. And if we get, I'll say 100 likes on this video, then we're gonna convince our teacher to dye his hair blonde. Thank you.
Hello everyone, welcome back to another Cranky Calculus video. This is your cranky classmate here with the Unit 2 review video on differentiability, rates of change, and derivatives. But before we get right into it, make sure to like, subscribe, and hit the bell icon to never miss another video and pass your AP test. So let's start with this FRQ right here. Question 1 gives us the velocity function of an airplane and a table with t values and v of t values. So let's take a look at part A. It tells us to approximate v prime of 5 on the interval of 4.5 to 6. In this case, v prime of 5 would just be equivalent to the average rate of change on this interval, or the slope. So we use the formula for y2 minus y1 over x2 minus x1. So let's solve that out. So v prime of 5 would be equal to v of 6 minus v of 4.5 over 6 minus 4.5. So that would just be 488 minus 500 over 1.5, which is negative 8. But don't forget to include units here. It sounds like common sense, but a lot of people forget to put units and miss an easy point. So right here would just be miles per hour squared, because v of t is in miles per hour and t is in hours. So since we're dividing by hours, it would just be miles per hour squared. Let's move on to part B now. It asks us if airplane A will reach a velocity of 500 on the interval of 2 to 3. So just looking at the format of this question, 99% of the time, if a question is phrased like this, which means asking if a function reaches a value on an interval, it's going to be an IVT or intermediate value theorem question. Now, for IVT to work, 3 things have to be true. The function has to be continuous on the interval a to b, f of a can't equal f of b, and the value we are looking for has to be between f of a and f of b. So let's solve this question using IVT. So first of all, we know that v of t is continuous on 2 to 3 because it's differentiable. Let's think back to the reasons a function is not differentiable. A function is not differentiable if it's not continuous. So if this function here is differentiable on the interval 2 to 6, that means functionally it has to be continuous on the interval 2 to 3. So second of all, we know that v of 2 is equal to 499, which is not equal to v of 3, which is equal to 503. And then third of all, we know that 500 is between v of 2 and v of 3. So this means, yes, airplane A will reach a velocity of 500 miles per hour due to IVT. Or, actually, by IVT. So we could just say, yes, by IVT, instead of writing this whole thing out, and that'll still earn you the point. Okay, finally we have part C. This question here gives us a function of another airplane, airplane B, and asks us which one has a higher speed at t equals 3. Looking back at the table, we know that v of 3 is equal to 500 miles per hour. So let's just write that out real quick. V of 3 is equal to 503. So now let's solve for p of 3 using the equation they've given us. So we know that p of 3 is equal to negative 15 plus 18 sine of 3 minus 3, which is just 0. So we know that sine of 0 is equal to 0. So that means that p of 3 is equal to negative 15. And the speed of this point means we take the absolute value, because velocity could be negative, but speed always has to be positive. So the absolute value of that would just be 515. And 515 is a bigger number than 503, so airplane B has a higher speed at this point. So the full justification for part C would be that airplane B has a greater speed at t equals 3 because the absolute value of p of 3 is greater than the absolute value of v of 3.